27. Scandium, titanium, iridium, chromium, manganese, iron, cobalt, nickel, zinc, nickel, copper, zinc. 21 to 30. 27. Total period table you should have idea properly. I said several times. Minus of plus 3. Minus of plus 3 will be minus of plus 3.
24.
Minus only, na? Plus 2 into coordination number evalada?
6. 6.
6 dative bonds formed. 6 electron pairs received. Why 2 into is there? Each dative bond donating how many electron?
2 electrons.
2 electron. So Z value is nothing but number of electrons also, na?
18.
So
Yes.
initially 27 electron there. 3 electron given out. Positive charge means given out. 3 electron given out. 24. Then 6 dative bonds lo 6 into 2 electrons is gaining. Total how many electrons there in the complex with the central
30.
metal? 36. 36 means matching with the which noble gas? Z.
Krypton.
Krypton. Bracket lo I am writing. Followed the EN rule. Right mark. Tell me. First answer me. You can write later. CO. Sol.
0.
Nickel.
0. 28.
28
sir.
minus 0 plus 2 into
4. 4.
4.
4.
Each dative bond 2 electrons coming 2 into 4. Answer 36. Again.
Krypton.
Then here go faster.
0. 0.
0.
0.
Ah.
26, sir.
Yes.
26. 0 plus 2
10.
into 5. 2 into
5 dative bond.
36. Again 36.
Don't write directly 10 ra. Don't write directly 10. Process wise you write. Because now you are understanding. Later you may forget. If process wise properly if you are writing now, later also you won't get doubt. In the similar way you write. Don't write directly the answer.
0. 0. 0.
24.
Minus 0 plus 2 into 6.
2 into 6.
Again 36. Again 36 will come Krypton.
Is it right? Next. So we will discuss. Okay. Here itself you can learn. You can directly write the exam. That much easy. In this lesson, so many things you can learn in class itself.
Completed. 1 minute.
Okay.
1 minute.
Okay.
Completed, sir.
Tell me the oxidation states first in all cases. After that, EAN will go.
First one +3, sir.
Yes, aluminum fixed valency directly you can go for that. +3. Otherwise, the +1, the -1, from that you can add. Tell me. This is Nessler's reagent, right? Familiar one.
Two, sir. +2.
This is +1, this is -1, so it will get +2. Right. Next.
+2, sir.
+2, correct.
+3.
Wrong.
Platinum 4, sir.
+4, correct. Hydrogen +1, chlorine -1. Count there. Summation of the oxidation states should be equal to 0 for the neutral species. Hexachloroplatinic acid, its familiar name. Inge.
2, sir.
This is +1, this is -1, this is +2. This is +1, this is -1, so this is +2. Sorry, this is +3, na? EN.
13, sir. Atomic. 3.
Properly 13 minus Z value 13 minus oxidation state. Go faster. Hey,
1, sir. 3, sir.
3 ra?
3, sir.
+3 na? Minus of 3.
2 into 4.
2 into 4.
Into 4. Answer.
18, sir.
Matching with any noble gas Z value.
Argon.
Followed the rule. Mercury.
80.
80, very good. Zinc, cadmium, mercury. Zinc 30, cadmium 48. Further 32 added, 80. 80 minus oxidation state.
2, sir.
2 plus 2 into
7.
86, sir.
86 means which fellow there?
Radon.
Radon means followed. Next is palladium.
46.
26.
2.
2. 2 into 4.
52.
52. Which noble gas is there?
No noble. Krypton.
No, krypton.
No noble gas.
Means followed or not followed the rule?
Not followed. Not followed.
According to Sidgwick, it is stable, unstable or less stable?
Less stable.
Unstable or less stable, you can say. Unstable or less stable. Next.
78. 78, sir.
Platinum. Nickel, palladium, platinum. Nickel 28. Add 18. 46. Palladium. Add 32. 78. Otherwise, you should have complete idea about the periodic table.
4 plus 2 into 6.
2 into 6. How much?
86.
86 correct. And then radon. So follow. Thing 26
sir.
minus
Minus of 1. Plus
Hmm?
2. Minus 2 plus 2 into 6.
2 into 6.
36.
36.
Doctor.
Here.
26 minus 3 plus 2 into 6.
Hmm.
35. 35.
Means
Not stable.
see there, according to EAN rule, potassium ferricyanide more stable, potassium ferrocyanide more stable. Ferrous plus 2, ferric plus 3. Tell me, potassium ferrocyanide more stable, potassium ferricyanide more stable according to EAN rule. Ferrocyanide more stable. But actually, ferricyanide more stable. Adi later you will get while I am discussing stability of complexes. Adi correct. Idi incorrect. Means some cases la EAN rule not valid properly, not giving correct information. These kind of things will be demerit for EAN. So many cases lo correct. Some cases lo like this not correct. What I am telling, potassium ferro K4 FeCN taken 6 more stable than K3 FeCN taken 6 according to Sidgwick, according to EAN rule. But actually K3 FeCN taken 6 only more stable. As later you will get charge of the central metal increase, CFSE value increase, stability increase like that. So this point will be demerit for this EAN rule. Like that, so many demerits also there, but so many correct also there. Write this. Some more example will discuss.
Completed.
Completed overall? Okay.
Completed, sir. sir.
Oxygen state, tell me.
+2.
+2, sir.
Yeah.
+1, sir.
+1.
Yeah.
+2, sir.
+2. Yeah. Very clear.
+0.
+3, here -1, here -1, here 0. Next. Okay.
Zero, sir.
Here +3 are not appearing. X plus 0 is equal to +3, na?
3, sir. +3.
Here.
-3.
-2. X plus 3 into -2 is equal to -3. X equal to +3. Other DMG charge.
-2.
Bah. DMG -1 ra. Equal to +2. Total charge -2 on anions. Z value, En value for this.
30 minus 2 plus 2 into 4, 36.
Very good. 36,
Yes, sir.
Yes, sir.
36 means followed, na?
Krypton. Sorry.
36 krypton, na?
47 minus.
Yes, copper, silver, gold. Copper 29, add 18, 47. 47 plus 32. Gold how much, ra? 79. 47 minus
1 plus 2 into
2 into
2.
0, na? 2 into 2, coordination number 2. Answer.
50, sir.
Matching with which fellow?
No matching, sir.
Not matching with.
Not matching.
Less
Not
stable.
followed this rule. Less stable or unstable according to EAN rule or Sidgwick. Next.
78 minus 2
78.
plus 2 into 4.
'84.
76.
24 correct. Not followed. Next.
26. 27. 26.
26 iron.
3.
27 only. -3.
Minus 3 plus 2 into 6.
6, 4, 2. 6 ligands there. 6 coordination number.
36.
36 means.
Krypton.
Yeah.
27 minus
27 minus 3
3
plus 2 into 3.
2 into 3 wrong. Tell me.
0.
2 into coordination number, na? Coordination number 0, na? How 6? 3 only appearing for me.
3.
3 wrong. 6 correct. How 6 correct?
Sir, 2 nitrogen will form a bond in
Ethylene diamine is bidentate ligand. Bidentate ligand, na? Each will form 2 bonds, 2 daily bonds. 3 will form 3 to 6 daily bonds. 6 daily bonds means 6 into 2 electrons. Understood, ra? Ethylene diamine monodentate, bidentate.
Bidentate.
Ethylene diamine will form how many daily bonds?
2, sir.
Then 3 ethylene diamine will form how many daily bonds?
6, sir.
6 daily bonds means how many electrons it will gain?
12, sir.
Now the answer.
36, sir. Krypton.
36, krypton of followed. Okay. Other
24 minus 6. 3 plus 2 into 6, sir.
there are 3 only there. Why 6?
Because that is bidentate.
Bidentate.
Bidentate ligands. Each will form 2 bonds. 3 will form 3 to 6 bonds. 6 bonds means 6 to 12 electrons gaining. Answer
33, sir.
33. Not followed. Next. Google
28
28, sir.
minus
2.
2.
Is 2 into 2 plus 2 into 6.
2 into 6.
2 plus 2 into 4.
DMG also bidentate ligand. Each DMG will form 2 daily bonds. 2 DMG will form 4 daily bonds. Answer 28.
36.
30.
34, sir.
34 means not followed.
Completed, sir.
Complete referral.
1 minute, sir.
Completed, sir.
These two also answer Banra.
+2, sir. Oxidation. Copper.
+2, yes, correct. Glycinate -1, correct.
+2 again.
Correct.
29, sir.
Copper 29, correct.
-2. +2 into 4, sir.
4, why?
Bidentate.
Glycinate also bidentate ligand. Answer
35, sir.
35. Not followed. Then
25 minus 2 plus 2 into 6.
25,
Again 35, sir.
special cases there. Structure also you should know. Here EN value of iron we had to find out. But 2 iron there. Discussing about 1 iron is enough. Discussing about 1 iron EN value enough. Why? Because both iron having same chemical environment. Check that same chemical environment there or not. Each iron having 3 terminal CO. Terminal means ending present. And each iron having 3 bridged ligands, bridging between the iron atoms. And iron metal bond also there. Metal bond or iron bond also there. Metal bond. Now you see. Terminal CO, how many electron giving to one particular iron? Each terminal ligand 2. Bridged ligand also giving 2 electron, but for how many iron atoms? Each bridged ligand giving 2 electron. Here CO is monodentate. It will give 2 electrons only, but 2 electrons to both the iron atoms. For one iron atom, bridge ligand giving how many
One,
electrons?
sir. One electron.
One. For two iron atoms, 2 electrons given by each bridged ligand. Then for one iron atom, 1 electron given by each ligand, correct? Each bridged ligand.
Sir,
Then
for
is
first it's terminal ligand. By each terminal ligand. Yes, sir, you have written bridge ligand. 2 electrons given by each terminal.
you confused. 2 iron atoms taken 2 electron by each bridged ligand. So for one iron atom, how many given by this bridged ligand?
Yes, sir.
I am explaining about the bridged ligand. 2 electron given by CO for 2 iron atom. Then for one iron atom, how many? Why? Because I have to express EAN value for one iron. Okay. Metal bond la, how many electron will be there? Metal bond consists of how many electrons? One bond la how many electrons ra?
2 electrons.
So each iron atom gains how many electron? Each iron atom gains how many electron in the metal bond? Each iron atom gaining how many electron? 2 electron for 2 metals. Each iron atom gains 1 electron from metal bond, or we can say iron bond. Hachingra, 1 metal bond there means 2 electron. 2 electron for 2 members. Then for 1 member, how many electron? Two electron for 2. How many electron for 1?
1, sir. 1.
Then EAN value, iron, Z value.
20.
Oxidation state evaldara?
Plus 3.
Hey.
So 2 electrons are gained
CO neutral ligand. Iron 0 na? Are you confused? Here gaining means covalent bond, coordinate covalent bond sharing idi, not transferred. CO neutral ligand or not?
Yes, sir.
Then iron oxidation state 0 na?
0.
Tell me here 0 plus 2 into 2 electron given by how many ligands? For 1 iron, 2 electron given by 3 ligands. Terminal CO groups plus 1 electron only given by how many ligands for iron? 1 iron?
2 ligands.
3 ligands. These are bridged COs. Then 1 electron gaining from
Another ions.
metal bond, or we can also say
Fe.
iron bond. Total evada
36.
36 means
Krypton.
means idi
Stable.
followed the EAN rule. Okay, these 3 one iron atom we are selecting. For this AN I am writing. These three 2 electron giving. These three 1 electron giving. This bond also 1 electron extra coming. You have to add. These are terminal COs. These are bridged COs. One CO will give 2 electrons to 2 iron atom. For 1 iron atom, 1 electron. Metal metal bond 2 electron there. For 1 metal, 1 electron. Understand?
Yes, sir.
Write this.
Completed, sir.
Completed, huh? Structure you have to remember, okay?
Completed, sir.
Can you say now? Structure already gave.
26 minus zeros.
0. All iron atom
Yes.
having same chemical environment, correct or not? All
Yes,
iron
sir.
atoms having same chemical environment, yes. Plus, all are
2 into 4.
terminal ligands only, no bridged ligand. So each fellow will give 2. 2 into how many ligands donating?
4.
4. These are from COs. Any other electrons it is getting extra?
Plus 2, sir.
1 electron by each metal bond. How many metal bond there for each iron atom?
2, sir.
Overall 3 metal bonds there, but for each iron atom 2 metal bonds. Total
16, 30, 36.
means
Krypton.
Write this.
Completed, sir.
Idi and rule clearly understood here itself.
Yes, sir.
Next, valence bond theory. Structure you have to by hand, you have to practice, remember. PBT given by Pauling. Some points to be followed. Metal may lose electrons, some electrons, which is indicating oxidation state of metal. May lose, not compulsory. Electronic rearrangement or reorganization may takes place even against Hund's rule. Pairing can occur against Hund's rule. Pairing of electrons occurs even may against Hund's rule based on the situation. Required number of vacant orbitals created. Required number of vacancies created and undergo suitable hybridization. For example, 4 ligands required, maybe sp3 or dsp2. 5 ligands approaching, maybe sp3d or dsp3. 6 ligands may approach, maybe sp3d2 or d2sp3. So octahedral structure here. In this case, trigonal bipyramidal. Here square planar. Here tetrahedral. Like this possibility there. After that, electron pairs will be given by ligands. So those electron pairs given by ligands can be placed, accommodated in these hybrid orbitals which are vacant. Then after all these things, till any unpaired electrons there, till any unpaired electrons, if any unpaired electrons electrons present then the complex is paramagnetic. You can count their n value, how much n is number of unpaired electrons. Then mu formula, several times you have seen this. Get rid of n into n plus 1 or 2 ara?
1, sir. 1, sir.
No.
2.
N plus 2 Bohr magnetons. Bm means
Bohr magnetic.
if n value 0, magnetic amount mu value 0, then that is
Diamagnetic.
diamagnetic. There are a lot of examples we are going to discuss. Follow these points. Metal may lose electrons, which is indicating its oxidation state. If not losing any electron, oxidation state 0. Then after that, electrons can be rearranged. Even against to Hund's rule, also pairing of electron may take place to create the vacancies. How many vacancies required? How many ligands approaching? What will be the coordination number? How many electron pairs is he going to receive? Accordingly, it will arrange. Those vacant orbitals, not unpaired electron case, not filled electron. Vacant orbitals undergo suitable hybridization like sp3, which leads to tetrahedral, dsp2, which leads to square planar, sp3d or dsp3, which leads to trigonal bipyramidal, sp3d2 or d2sp3, which leads to octahedral. Then electron pairs given by ligands can be accommodated or placed in these hybrid orbitals. Till now, any unpaired electron there, the paramagnetic magnetic moment you can calculate with mu is equal to square root of n into n plus 2 Bohr magnetons. Bohr magnetons. If no unpaired electron found, then mu value 0 diamagnetic. This is theory. Write these points. Completed ra?
Yes, sir.
Sir.
Yes. Tell me.
Completed, sir.
Completed, sir.
Completed, sir.
COF63 minus, where F minus is weak field ligand. This is one clue. Whenever weak field ligand is there, no electron pairing, Hund's rule not violated. No electron pairing or electron reorganization. Reorganization not taking place, as it is what there in the similar manner. COF63 minus. Weak field case. Weak field, strong field, strongly influencing, weakly influencing, like that will be there. Other example for weak field, water and remaining halogens. Then here cobalt Z value, you know what is the Z value of? (27). So that configuration is 4s2 3d7 adi. 4s2 3d7, which is outermost shell here. Fourth or third?
Fourth.
Here, what is the oxidation state of cobalt, amma?
+3. +3, sir.
+3. Then cobalt +3. From where I have to remove the electron? 3d or 4s?
4s, sir. 4s.
Always this is possible to remove the electron from outermost shell only. It is impossible to remove the electron from inner shells. You have to remove one by one from the outermost shell only. Outermost completely if you removed, then you can go for the next orbit. That will be the outermost now. From that you can remove the electron. You cannot pick up the electron from inner shell directly. It is practically impossible. Actually, electrons entering 4s first filled, next electron entered into 3d. Actually, the last electron is this 3d 7th electron entered, last one. But you can able to remove the electron always from last shell. Never, you can never remove the electron from inner shell directly. Okay, so from outside 2 electrons gone, but 3 electron you have to remove. Na? Here 1 electron means 3d6. Overall now 3d6. So cobalt 3d. 1, 2, 3, 4, 5, 6 electrons in 3d. But it is having 4s orbital. 4p orbitals free only, vacant. 4d orbital also vacant. How many ligands?
6. 6 ligands.
Each ligand will donate how many electrons?
1.
Each ligand can donate how many? One pair. So how many pairs? Now overall 6 pairs. 6 vacant orbital irukka inge?
Only 4, sir.
Yes.
It is there.
They should undergo suitable
sp3d2.
sp3d2 hybridization. Actually, inner shell d orbitals also there, but they not underwent hybridization here. Outside d orbitals utilized. So sp3d2 means the octahedral structure. Very simple to draw octahedral structure. Already Werner's serial I have seen. Yes. Overall charge -3. Okay, outer orbital utilized, outer d orbitals utilized, outer d orbitals. So that this is called as outer orbital complex. Very important. Also called as spin. You see, number of unpaired electron evadara 4 na.
4.
Whenever 4 there, mu value will come 4 point something na 4.9 Bohr-Manadon. Paramagnetica, diamagnetica. Paramagnetic. So spin freely present. Spin not paired here, freely present. Very high spin value coming. Plus of. Total how much? High spin. So weak ligand field there. So called as weak field complex. Is also called as high spin complex. Also called as spin free complex. Outer d orbital utilized, so that outer orbital complex. One example only we will discuss. We discussed. We will discuss 10 more examples. First you have to write this. Write quickly. If pending is there, next class we will discuss. No problem. We can write. Try to finish within 2 minutes.
Completed, sir.
Actually, so many examples I will discuss. Slowly you can understand, your understanding level will increase. For examples I explained means remaining examples you will only solve. So I will take your help only to write. So automatically you can understand. Here itself you can learn. No need to specially practice again. Understand? This outer orbital, everything starting level you have confusion. Just wait for 3, for example. Means next class itself it will be very clear for you.
Completed, sir.
Right, thank you all.
Thank you, sir.
Next class we will continue this. Okay, no time.
Thank you, sir.
Right, thank you.
Thank you, sir.
Thank you, Amma.
Thank you, sir.